Great. Hi. My name is Morgan Muir, and the time has come to start our little webinar on the altherma from Daikin. What we're going to have today is hopefully about a 40-minute introduction, an orientation to the product and what it means and applications and what it is, and then a discussion of resources available surrounding the product and the design of the product. One of those resources is our website. And hold on one second, I'm having a switching slide problem here. There we go. One of the resources is our website, jtgmuir.com /altherma, and we'll go into this in some depth later on. You can look at a video of the altherma functioning. Over here, you'll see all of the technical data and related data to altherma, and that soon, starting next week, you'll see a series of small PowerPoint presentations on various aspects of the altherma, which you can use as a resource there. So, first of all, who is Daikin? Some of you may not be familiar with them because they have not been a major force over the years in America, but they are number 2 in the world after Carrier. They're about to become number 1, and they're moving very aggressively with a whole range of products into North America, purchasing manufacturers, setting up facilities across the country. They are the world heat pump technology leader. They developed the inverter technology we'll talk about, and a variety of other things relating to heat pumps, because that is their only business, HVAC. Altherma is not just something cooked up in a garage somewhere. 2008, there's over $1 billion of sales of these products, and I'll tell you, the quality control is just stunning on these products. Just very few reported problems throughout Europe. So when you get to know Daikin, they have a central green philosophy that goes right from the screws they purchase in their plants all the way through their product lines with what they refer to as the renewable energy heat pump technology. Also altherma, so you know, is a separate division. Of Daikin on hydronics. So they do have a variety of other products, mini splits, variable volume, and so this is separate. Again, why I'm doing and ah, I'm getting messages put in front of me as we go along here. So, what is the altherma? It's an air-to-water heat pump, and for us in the hydronic business means that we now have a complete hydronic package. And as we'll see, a very green appliance. It does hydronic heating, does hydronic cooling with chilled water, it does domestic hot water through an indirect water heater. It integrates solar hot water seamlessly, and as you'll see, it's very solar electric friendly, which is an important feature of this product within the California marketplace. So in fact, this is our holy grail that we've been awaiting in the hydronic industry to expand our market very much more widely, to be able to include integrated cooling solutions, as well as being in California, being very low NOx is an important aspect of the overall policy initiatives going on in California. So the heat pump basics, what heat pump does is, using in our case air, extracts energy and is employed within a refrigeration process where the power into the unit is into the compressor, and this change of state that occurs in the evaporative and condensing process is where there's a great energy boost that is much 300% greater than if you just burn natural gas or fuel oil directly. So the Technology has evolved tremendously since the 1970s and 80s, when we had heat pumps that could only manage to go down to 38 degrees ambient outside before going to electric strips. These are low ambient heat pumps that will work down without electric strips down to -4 Fahrenheit with very reasonable COPs. We'll get into that. So when we look at a heat pump, on the left-hand side we have a gas-fired appliance. If you put in, if you have 1.1 kilowatt of gas, and we're going to work in kilowatts here just to have equality, with the 90% unit, you'll generate about 1 kilowatt of heat going into a system. And this is essential that this is in people's minds, because in the case of a heat pump, you take, to get 1 kilowatt of heat put in, you use basically a third of that to generate the kilowatt. So the heat pump is boosting efficiencies by 300 to 400%. We're using a COP of 3 here, which would be about the minimum you'd be able to generate in our Mediterranean zone, climate zone in California. More typically, we're in the 3.7 to 4.3 COP in California, Mediterranean zones. So as a result of this, the altherma actually in terms of CO emissions is substantially less than gas boilers and a lot less than a fuel oil boiler, even when you account for natural gas being burned in the utility and transmission losses. Still, the boosting factor of the heat pump creates a low emission device. So some quick notes here. So the unit operates without electric strips at low ambient temperatures, operates above COP of 3 at 20 degree F design temperatures. We'll find that 85% of California is in terms of population, has a design temperature above 20 degree Fahrenheit. When we run the computer programs here, which we'll go through, we're typically seeing COPs of 3.6 to 4.2 in California annualized. Provides the same COP, less standby losses for domestic hot water. So the domestic hot water is about twice what you'll see in terms of performance with this type of device compared to a standard heat pump water heater. And while we can go into the performance issues a little later, the EERs will be 10 for cooling or more on the smaller units. Backing up a little bit of understanding of the economics of energy in California. What we have in this top section, what we're doing here is we're converting equivalency costs of energy to gasoline, a gallon of gasoline, which is something I think all of us can understand. California has the most expensive electricity in the United States. The average in California, outside of California, is about 8 cents a kilowatt. You can see where our lifeline started. It's actually now about 11 cents a kilowatt and move up to 44 cents a kilowatt. I had a quick question here of COP. COP is coefficient of performance. Electric water heater or electricity resistant would be 1. So COP is how much more energy you receive out of your kilowatt input in terms of energy. So a COP of 4 would be you're receiving 4 times the energy output for a kilowatt input. Notice that the tier system, which is